So we continue with from the last video. So we said that the consultant has four alternative: do nothing with $0, vegetable market with the initial cost 50,000 and uniform net annual benefit 5,100 and terminal value at 20 years 30,000. Alternative C is gas station, make gas station in the land. So we have to initial cost 95,000, uniform net annual benefit 10,500 and terminal value is 30,000. And D, small motel, we construct small motel. The total investment is $350,000. Uniform net annual benefit 36,000 and terminal value is 150,000. Include the land and structure but does not include the 8,000 free fee for the consulting firm. Assuming 10% interest, the minimum attractive rate of return, calculate the present worth of each case. Solution. First of all, we don't take an account 8,000 because it's considered as sunk cost. That's mean it's already paid before, so we cannot make decision based on the past. So 8 million for the consultant is not considered. Alternative A, do nothing. So the net present worth is $0. This is the first alternative. Do nothing, so the net present worth, this is net present worth, NPW. Alternative B, vegetable market. So net present worth, we have investment of minus 50,000 and we have uniform series during 20 years 10%, 5,100, looking for P given A 10% 20,000 plus the terminal value, it's 30,000, it's in the future, so looking for P given future value 10% 20%, 20 years. So we calculate, we get 2,000 minus 2,120. That's mean the project or the alternative B, we get a loss of 2,120. Now if you go to alternative C, net present value is the initial cost minus 95,000. We have a uniform benefit every year 10,500. So looking for P given A 10% 20 years plus the final value 30,000, looking for P given F 10% 20 years. So we calculate, we get minus 1140. So alternative C, we get a loss. And alternative C, small motel. So net present value, we have the initial cost minus 350,000. We have 36 uniform series. So looking for P given A 10% 20 years plus the final value 150,000, looking for P given N 10% 20 years. So we get minus 21,210 as a loss. So the best alternative is the first one because the alternative 2, 3 and 4, then we get a loss instead of benefit. So the alternative is do nothing. So we don't need to pay the land and make a project. Example, another example. A piece of land may be purchased for 610,000 to be strip mined for the underlying coal. Annual net income will be 200,000 per year for 10 years. At the end of 10 years, the surface of the land will be restored as required by federal law on strip mining. The reclamation will cost $1.5 million, more than the resale value of the land after it is restored. Using a 10% interest rate, determine whether the project is desirable. So year 1, year 0, the beginning of the cash flow, we have to pay $610,000. Between 1 year and 10, we take a benefit is 200,000 per year, and at year 10 we have to pay $1.5 million. It's minus here, positive here. So net present worth is minus 610,000 plus 200,000 looking for P given A. This is every year because every year 10%, 10 years, minus 1.5 million looking for P given F, 10%, 10 years. So when we calculate, we get plus 40,750. So the project is desirable because the net present worth is positive, is bigger than 0. So we make a benefit when we make the project. So it's better to make the project, and we get at the end net present worth 40,750. So the project is we can take a benefit. So this is how to make a decision using the present worth analysis. You can another example, 2 pieces of construction equipment are being analyzed. So we have the cash flow here. Here 0, we have a cost of minus 2,000 for alternative A, and minus 1,500 for alternative B. And after that we have different cash flow. So alternative A is a cash flow like that: 1,850, 700, 550, 400 uniform series, and we have the cost 2,000. For the second one, we have uniform series of 300, and after 50 years we have increased by 100, and the cost is 1,500. So present worth of benefit for the alternative A, we have the uniform series during 8 years, so 400, looking for P given A, 8% the interest rate, and 8 years. This is for the different value here. After that we have a gradient, decreasing gradient. So it's 600, because we take 400 from here, so we get only 600 here. Here we get 250, here we get 300, and here 450, 300, and here 150. So it's a decreasing gradient, so it will be 600, looking for P given A, 8%, 4 years. So we have 1, 2, 3, 4, 0, 1, 2, 3, 4. So 4 years here. And minus, since it's decreasing, so the gradient will come with minus. Minus 150, looking for P given G, 8% for 8% for years. So we calculate, and we have the present worth cost is 2,000, which is the initial cost. So when we calculate, we get present worth of benefit is 3,588.5, and the present worth of cost is 2,000. So the net present worth is the difference between the present worth of benefit minus the present worth of cost. So it's 3,588.5 minus 2,000. So we get a benefit of 1,588.5. So this is for alternative A. For alternative B, the present worth of benefit, we have 300 here, uniform series of 300. So it's 300, P, looking for P given A, 8%, 8 years, plus 700 here. 700 here, we take out 300, so we get 400. 400 in this case, so it's 700 minus 300, which is 400. Looking for P given F, 8%, 1 years. We transfer this 400 to the present value here. After that, we have a gradient here. We took already 300, so we get 0 here. We got 100, 200, 300. So it's a gradient increasing, so it will be 100. Looking for P given G 8% for years, and this value, be careful, the gradient will be reported here. So we have to report it also to the present value. So there is 4 years, so that's why we use this to calculate the gradient, and after that this to transform it to the present value. So it's P looking for P given F 8% for years. So we calculate, we get present worth of benefit 2,436.24. The present worth of cost is 1,500. So when we calculate the net present worth, it's the difference of this minus this, we get 936.24. So here it's the benefit is 1588.5, and here the benefit is 936. So it's better to take or to make this alternative. Okay, to maximize net present worth, we choose alternative A, which is we get net present worth, the maximum net present worth. So this is how to make decision between two alternatives. They have the same useful life and different cash flow. This is already solved, and this is already solved. So thank you very much for your attention, and if you have any problem regarding this issue, this chapter, please don't hesitate to ask me using email or during the next lecture. Thank you very much. Today we are going to continue our chapter number 5, which is about present worth analysis. So we saw in the previous video when the useful life is the same as the analysis period. So we said that this is